Biomedical waste management is a critical discipline within healthcare that ensures the safety of patients, staff, and the environment. This field involves the systematic collection, segregation, and disposal of hazardous materials generated during medical procedures. Effective management is not just a regulatory requirement, but a moral obligation to prevent the spread of infectious diseases and toxic contamination. Throughout this presentation, we will examine the strategic frameworks, behavioral shifts, and sustainability goals necessary to maintain a robust and compliant waste management system in modern medical facilities. Proper handling of these materials is the foundation of a safe healthcare environment. 10 IEC strategies, sensitization, and future sustainability represents the final and most forward-looking chapter of our study. This section focuses on the human element of waste management, moving beyond simple logistics to address how we communicate and maintain high standards over time. IEC stands for Information, Education, and Communication, which are the pillars of institutional change. Sensitization involves making every healthcare worker aware of the impact of their actions, while future sustainability ensures that our current practices do not compromise the health of future generations or the planet's ecosystems through pollution or resource depletion. Lesson 10.1, The Behavioral Bottleneck, addresses the psychological challenges in waste management. Advanced infrastructure fails if frontline workers suffer from cognitive overload, meaning even the best technology is useless if staff are too overwhelmed to use it correctly. Human habit and apathy at the point of generation are the primary failure points in the system. When a worker is rushed or tired, they may revert to old, incorrect habits or simply stop caring about proper segregation. Addressing these human factors is essential because the point of generation is where the most critical mistakes occur, leading to dangerous cross-contamination. Lesson 10.2, IEC Campaigns, focuses on the strategic implementation of information, education, and communication. These strategies drive institutional behavioral change by moving the culture of a hospital towards safety and compliance. These campaigns must do more than just provide rules. They must persuade stakeholders to understand the direct benefits of hygiene and compliance. When staff members realize that proper waste management protects their own health and the health of their families, they are much more likely to follow protocols consistently. Effective communication transforms a burdensome task into a shared value within the medical community. Lesson 10.3, Visual Reinforcement, provides practical tools for ensuring compliance on the floor. Hospitals should deploy highly visible, language-agnostic, color-coded charts that provide instant guidance on where waste belongs. These charts use colors rather than words to convey meaning quickly. Additionally, universal biohazard symbols placed directly above bins bypass linguistic barriers, ensuring that everyone from surgeons to cleaning staff understands the risk. By making the right choice the easiest choice through visual cues, we reduce the cognitive load on workers and significantly decrease the likelihood of disposal errors in high-pressure environments. Lesson 10.4, Eradicating Open Burns, addresses a critical environmental and public health issue. We must implement aggressive campaigns targeting rural centers to eliminate open waste burning, which is often used as a shortcut for disposal. This initiative specifically stops the highly toxic cultural practice of burning waste for winter heating. While it may provide temporary warmth, burning medical plastics and chemicals releases dioxins and furans into the air. Education is vital here to explain the long-term health risks of these toxins, which can cause cancer and respiratory issues, far outweighing the short-term benefits of heat. Lesson 10.5, Mandatory Training Audits, introduces accountability into the management system. Administrators must formally track and report staff training metrics to ensure that no employee is left behind in the education process. Furthermore, Form IV returns must display the exact ratio of trained versus untrained personnel. This level of transparency ensures that management cannot ignore gaps in knowledge. By quantifying training, facilities can identify specific departments that need more support and prove to regulatory bodies that their workforce is competent and capable of handling hazardous materials safely and according to the law. Lesson 10.6, Pandemic Agility, explores the need for systems that can handle extreme stress. Global crises cause unpredictable spikes in infectious waste, such as massive amounts of PPE and test kits, which can overwhelm standard disposal routes. Therefore, modern BMWM systems must be elastic and scalable to absorb these macroeconomic shocks. This means having contingency plans, extra storage capacity, and flexible contracts with waste processors. An agile system can expand its capabilities during a surge without collapsing, ensuring that infectious waste never accumulates in patient areas during a public health emergency. Lesson 10.7, Combating Antimicrobial Resistance, or AMR, highlights the link between waste and global health threats. Proper pharmaceutical waste destruction is a frontline defense against AMR, as it ensures that antibiotics do not leak into the water supply. This practice prevents the environmental breeding of multi-drug-resistant superbugs. When discarded medicines enter the ecosystem, they expose bacteria to low levels of drugs, allowing them to develop resistance. By incinerating or chemically neutralizing pharmaceutical waste, we break this cycle and protect the efficacy of life-saving medicines for future generations of patients worldwide. Lesson 10.8, Climate Change and Decarbonization, looks at the environmental footprint of healthcare. The healthcare sector must aggressively pursue energy-efficient disposal technologies to reduce its overall impact on the environment. Mitigating the carbon footprint of medical transport and incineration is vital for planetary health. This involves optimizing logistics to reduce fuel consumption and adopting non-incineration technologies like autoclaving where possible. As healers, the medical community has a responsibility to do no harm, which extends to the planet. Decarbonizing waste management is a key step in creating a truly sustainable and eco-friendly healthcare system. Thank you for your attention throughout this lesson on biomedical waste management. We have covered the critical importance of behavioral change, visual aids, training audits, and the broader impacts of our work on climate change and antimicrobial resistance. By implementing these IEC strategies and focusing on future sustainability, we can ensure a safer environment for healthcare workers, patients, and the community at large. Remember that every small action at the point of waste generation contributes to a much larger global effort towards safety and health. We appreciate your commitment to maintaining the highest standards of waste management.